Today, we're going to talk about something that's part art, part puzzle, and all math, arithmogons. These visual puzzles are a pretty amazing way to start thinking in a way that makes something like algebra finally make sense. So, what if I told you that this simple little diagram, just a few circles and boxes, is actually a secret doorway to understanding algebra? I know, it looks like a kid's game, but it really holds the key to seeing math in a whole new light. Okay, so let's get down to it. What in the world is an arithmogon? It's actually pretty straightforward. An arithmogon is basically a picture puzzle. You've got numbers in the corners, right? And the numbers on the sides in those boxes are what you get when you apply a rule, like adding or multiplying, to the two corners they're connected to. Let's start with the classic version, the one you'll see most often, the addition arithmogon. All right, here's our first challenge. We've got the sides, 14, 18, and 16. Those are the sums. Our mission, should we choose to accept it, is to figure out the mystery numbers A, B, and C in the corners. Now sure, we could guess and check all day, but there is a much cooler way to do this.
And here it is. This is the elegant method. It's a simple, four-step process, but the beauty of it is that we're looking at the whole puzzle at once, not just one piece. We're using the structure of the problem to solve itself.
Step 1, just add up the sides. 14 plus 18 plus 16. That gives us 48. Easy enough, right? So what's so special about 48? Well, think about what we just added. We added A plus B, then B plus C, then A plus C. Did you catch that? Each corner, A, B, and C, got counted exactly twice. So that 48 is actually double the sum of our corners. To find the real sum of just A, B, and C, we just chop it in half, and that gives us 24. And that number, 24, is the master key to the whole thing. And now for the really cool part. We know A plus B plus C is 24, and we also know from the puzzle that A plus B is 14. So, to find C, we just subtract. 24 minus 14 leaves us with 10. And we do the same thing for the other corners, always subtracting the opposite side from our magic number, 24.
And there you have it, our completed puzzle. The corners are 6, 8, and 10. Let's just do a quick check. 6 plus 8, yep, 14. 8 plus 10, that's 18. And 10 plus 6 is 16. It works! A perfect fit.
So, the method obviously works, which is great. But the real magic, the real learning, is in understanding why it works.
This is probably one of the most important questions you can ask in math. Yeah, we found a trick that gives us the right answer. But why? What's going on under the hood here that makes it all possible?
Here's the secret. It's all about the structure. Because every corner connects to two sides, its value gets used in two of the sums. So when we add all three sides together, we automatically, without even trying, count every corner's value exactly twice. That's it. That's the insight that makes the whole thing tick. So, if this method is really all about the structure, then the same logic should work even if we change the rules, right? Let's find out. Let's switch from addition to multiplication. Just take a look. On the left, our old friend, the addition arithmogon. On the right, a multiplication one. See, the skeleton, the structure is identical. All that's changed is the operation. Now the sides are the product of the corners.
All right, here's our new challenge. The sides are 12, 24, and 18. This time, we need to find three corner numbers, A, B, and C, that multiply to give us those values.
We're going to use the exact same structural logic. Instead of adding the sides, what do you think we're going to do? We're going to multiply them. So 12 times 24 times 18 gives us this big number, 5,184. And just like before, that big number has each corner value counted twice. When we multiply A times B by B times C by A times C, we really get A times B times C squared. So to find the product of just A, B, and C, we do the opposite of squaring. We take the square root. The square root of 5,184 is 72. And just like that, we have our new magic number, 72. The product of all three corners is 72. So to find corner A, we divide 72 by the opposite side, which is 24. You see how the logic is exactly the same? It's perfect. And there's our solution. Let's check it. 3 times 4 is 12. Check. 4 times 6 is 24. Check. And 6 times 3 is 18. Another perfect solution, and we got there using the same kind of thinking we used for addition. Look, solving these has been fun, but arithmogons are so much more than just a little puzzle. So why does mastering this simple-looking triangle actually matter? Because they're basically a gym for your mathematical brain. They teach you to look for relationships instead of just jumping in and calculating. They make you reason from the structure of a problem, and they help you see connections between things like addition and multiplication. But most of all, they get you into the habit of explaining why something works, and that, right there, is the heart and soul of doing math. I'll leave you with this fantastic quote. Arithmogons aren't just small puzzles. They really do build these deep, flexible ways of thinking. They're kind of the perfect bridge from just doing arithmetic to really understanding the world of algebra. So next time you see a math problem, maybe ask yourself, what's the hidden structure here just waiting for me to find it?